What the heck? What is this? What? Why did that jump down there? What is the purpose of this? Let's find out. Hello, and welcome to today's episode in which we will be talking about UVs. So, to begin, what is a UV? So in 3D, you might think UV stands for something, but it just refers to the 2D coordinate system used to place textures on a 3D model. So we use U and V. U is typically the horizontal, and V is typically the vertical, to avoid confusion with the 3D axes in 3D, which is X, Y, and Z. X being here, Y being here, and then Z being up here. So a UV map is a flattened 2D representation of a model surface that tells the renderer where each pixel of a texture should appear on the 3D object. A UV looks like the 2D representation of the 3D model it is based off of. So we mentioned this in what is a UV, whereas we're going to go a bit deeper into what they look like. If we select all the faces here, we'll be given this net, and if you remember from your primary school days, for example, if you had this on a piece of A4 paper, cut off the excess and then forwarded along the lines here, 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 here and here, you'd be given a cube. Granted, you'd have tabs, say, with glue on it there, and then that would glue to this edge here, and that is essentially how we made our cubes in primary school from a 2D shape. So that's not lost on any of the other shapes. If we bring in a UV sphere, we have all these teeth at the top that come together, and that is what is right here. And as you can see, there they are, they're right there. The cylinder, for example, is just two circles with a rectangle wrapped around it, so that is essentially what this is. And one other thing is the torus, for example, which is basically a flattened A4 piece, because if we were to select these edges and we were to split them like so, and then what we can do is we can grab this face, make sure we've got this on. So just as an extreme scenario, what this does is it basically just shows that what we've got is our 2D piece of paper essentially, because if we do this and then we split this one down the middle, and then what we can do is just select that, and then if we just to an extreme just drag it out a bit like this, this is our piece of A4 paper. Granted, very stretched, but yeah, it basically comes down to that. So just as a quick visualization, I'll just bring in this cube that will generate from our planes, for example. So it's there, here, here, and then we need two more going down this way. So like so, then what we'll do is we'll just make sure all these are joined together and they all have merged vertices. So like so, what we'd have is, if I just change this to the active element, so if we had all of these, we can rotate this on the, we'll make sure this is turned off, we can rotate this on the Y by -90, we can rotate this on the Y by 90, we can rotate this one on the X by -90, and then same again with this, we can select all of these and then rotate on the X by 90, and then lastly we can rotate on this X by 90, like so. There you go, that is essentially what we did. We had our cube. Granted, because they were planes, this is how they look now, but if we were to merge by distance and then we smart UV project, for example, we'll just get this. Anyway, we cover this later in the episode, but essentially that is what it is. It's a 2D representation of the 3D model. So why do UVs matter? They are essential for texturing. They determine how a 2D image wraps around a 3D shape. So going back to our cube idea, if we go back to our primary school example where we can draw 1, 2, 3, 4, 5 and 6, we basically did texturing and UV unwrapping before we actually came to doing it in our 3D software. So this is a rough example, but if you want to see the real example, all we have to do is pull up the shader editor, make a new material, and then image texture, and then we're just going to call this our die, like so, and then we're just going to call this die, keep everything as it is. And like I say, so this is our UV, it's this T shape that we've got here, like so. So what we should see is in our UV editing tab, it's the same, and then in our texture paint, we've got the exact same shape here. So if I draw a 1 like so, we'll find the 1 is here, and then adjacent to it we should find a 2 like so, and then 3 should be here, along with 4 being there. Looks like an upside down 7. Right, so judging by how this would be unwrapped, we can see that the back of the 3 is here, so this means that this face should be 5. And then the opposite side will be 6. Accidentally went off there, so 6. Like so. So that is how we can map our textures to our 3D objects. So we've got our 2D shape turned into our 3D shape. And just to showcase this a bit more, if we bring in a cylinder, for example, we can see that this is the main body of the can, right here. And then we've got the top, and then we've got the bottom, like so. So I've already made a texture just specifically for this, and what I'm going to do is type in image texture, connect it up, and then I'm going to open it from my downloads folder. And then it should be UVs, can texture, like so. So we've got our material preview, and then this is our Blender UV soda. So if we have a look at the UV here, we can see that the top of the can is with circle 1, the bottom of the can is with circle 2, and then the main body is within this rectangle. So this is how our images or our textures get mapped to our 3D object. UVs are connected to the geometry, don't get me wrong, but adjusting UVs changes how a texture is applied without altering the model's geometry. So if we were to bring back our die and give it our die texture, and then we were to look at our 2D version of it, we can see that all of the die's faces have equal UV space, and that's because if it was to be used as a die, they would have equal opportunity of showing up. But what we're getting at is if we were to rotate our UV island for face number 1, or scale it, or even move it to 3 for example, we're not actually moving this face or rotating it or scaling it up and down. So that's what I mean by they're independent. The UV doesn't actually impact the geometry. But what we should take away from this is that we can prioritize what gets more resolution by simply scaling up or rotating. So a better example for this would be if we pulled up a billboard. So if we scale this down on the Y, massively bring it out on the X and increase it by the Z, move it back so we can see it a bit better, apply scale and then just inset the face a bit so we've got our poster there. And then if we give it our die texture, we can see that our main advertisement here has the same UV space as this strip here. That just doesn't seem fair in any way, shape or form. The back, which no one sees, also has the exact same UV space as this. So this is where we will need to unwrap. So if we unwrap by following active quads, for example, this seems to have fixed it to some extent. So now what we can do is we can scale this up like so, and then we can bring it down as well. If we were to bring this, for example, and because the back isn't really seen, we can either just delete the face, for example, Or what we can do is we can shrink it down so it takes little to no UV space, full stop. But what we want is we want to see these, and then we want to give our main billboard advertisement its own place. So we can increase it like so, and then that's what we've got. Only issue is we've also got it as a square as opposed to a rectangle. So another thing that we can do is if we select all the faces is we can smart UV project, which hopefully keeps everything to the same sort of ratio as it is in the 3D space. So we can see that this is our screen and this is our back. So our screen should be slightly smaller than our back accordingly, just a little bit. And then we've got our perimeter here, and then we've got our inner perimeter there. Issue is when you do smart UV project, if we had edge wear, for example here, we can't really get it smoothly because, as you can see, our outside perimeter is a square, so any texture that could, in fact I can just showcase this, if we were to draw along that corner there, if we make it white as well, if we draw on this corner here, we'll see that it paints the corner there. Only issue is if you were to paint into the corner there, we'll get a random dot here, a random dot there. So you have to pick your battles with UV unwrapping, but we cover UV unwrapping later in this video. But the main takeaway from this segment is that you can scale, rotate or move these UV islands, the flattened pieces, to prioritise texture detail where it matters most. And an example would be giving a character's face more UV space than the back of their head. UVs work together with texture resolution. More UV space equals more texels per surface area. So a 4K texture will show more detail than a 720p texture for the same UV layout. Consistent texel density across important parts of a model helps avoid visible resolution mismatches. So I'm just going to pull up a cube here, and then what we're going to do is we're going to call this our 4K cube. Create a material, and the material is also going to be called 4K cube, and then we're just going to make an image texture, and believe it or not, that is going to be called our 4K UV grid, like so. And then we're just going to make these numbers 4096, and then we're going to give ourselves a UV grid like so. So this is what our 4K texture looks like, a lot of squares and a lot of rainbow pluses. So we're going to move this over to the right a little bit, and then we're going to duplicate this, and then we're just going to park it right next to it. So as you can see, almost flawless. In fact, it does look flawless, you can't even see the seam. But anyway, this is going to be our 2K cube. We're going to duplicate our texture and call this our 2K cube. And then, believe it or not, we're going to duplicate this and call this our 2K UV grid. Got you again. So that will be 2048, like so, and then new image. So as you can see, we've already got a quality drop. I mean, don't get me wrong, it still looks like clean squares, and that's because 2K is fine, 1K is also fine, realistically, within the right reason. So this is going to be our 1K cube, and then we're just going to duplicate the texture, call it 1K cube, and then we're going to have our 1K UV grid, and then this will be 1024. So as you can see, basically the more we have, in a sense, so as you can see, this is quite a large image square, and then we've got this one which is smaller, and then granted we've got this one that is smaller. So basically what we've got is, if we have a high resolution, it just means we've got more pixels to play with to apply detail to our meshes, and this is an example of why you wouldn't put 4K textures of stuff next to a 1K texture of something, unless this 1K item was really small, which is where you can start lining these dots up, for example. So if I was to park that next to there, and then if you were to like look on from the side, like so, and then if we just scale it up until it, you know, something like that. See, we can barely see it. So yeah, you just got to pick your battles, but if you want more detail into texture resolution and texel density, we do a deeper dive in another video that will be coming out shortly after this one. So when that video comes out, I'll make sure on your screen right now. Unwrapping basically just means where do we cut our geometry so that it can be turned into a 2D object. Think of it as the opposite of our primary school method in which we turned the net into a cube. We're now turning the cube into a net. So for example, we want to recreate the long strip here, we want to get that one there, and then on the other side we want to get that one there. So what we need to do is we need to select the edges, as these are our edges that we cut with a craft knife, scissors for example. And what we're going to do is select these 3 edges here and then click mark seam. So the way to visualize this is the face is now going to fold open like a cardboard box lid. And then we know that we want this bottom one to also fold outwards like this. So what we're going to do is select these 2 edges here and mark them as a seam. So now we've got our flat piece here. We want our side face on both sides to also do that. So if we mark our seam here, they will now fold out that way, and then this one will fold out this way. And because we've already marked these seams, this one is just automatically done for us as a result. And the bottom one can stay as it is because everything is unwrapping from that base square. So just an example, we could smart UV project this like so. I mean, this is the quick and lazy method, and what you'll find is our texture is now mismatched. We could grab a square and then try and align it, but that can take time, especially if you're dealing with a character's face, for example. So what we'll do is we'll select all our faces and unwrap angle based, and it will treat all of these like this is where we've gone round with our scissors. And now we've got our T-shape for our cube. So now our textures somewhat line up better. We've got our green pluses going this way, and that is because these faces are connected. If we were to look at this one and this one, for example, where they're at opposite ends of the UV grid, we'll see that pink lines up with orange, green lines up with blue, but as a line up, red lines up with red, but it seems to be that the top face is inverted to the adjoining face. So even though red's in the same place, pink is either side, then purple is either side, and then blue. So yeah, basically this is why we UV unwrap. It's because we get more control of how our textures look. Our can, for example, we can see that our seam is visibly down the back, because if I was to select this tool here and select the edge there, we'll see that these 2 are the same edge. And basically we can fix this by having a tileable texture, for example, but what we tend to do is we will just have this in our shot and then basically not look at the back of it. Another thing that can happen with UVs is we can get bleeding of the islands. So basically each of these, so this circle is an island and this is an island, and as an extreme case I'm going to import a cylinder and just unwrap this like so. And then what we're going to do is we're just going to show what texture bleeding looks like. So this is more of an issue with low resolution textures, so I'm just going to keep it as a 1K texture. So I'm just going to call this texture bleed. And basically, yeah, what can happen is if we just come to the top here and then paint the top like so, we'll see that we have these sort of cutouts where we can't make it white. We can if we come down the side and paint it like that. Now it's pristine, but now we've got white sides. One way to fix this is by either increasing our UV island, which we should because that's quite a small space, so we can just do this, for example, which means now we can have more texture space, but as you can see, we still have, granted it's smaller, but we still have this bleeding into our sides and slightly into our top. So two ways to sort of fix this, either higher resolution images, or if we go into our UVs, we can slightly, if I just invert the selection here and then select those edges, we can slightly grow them out of the way. So now if we go to our texture paint, we can now paint the top more clearly, because the top face is now just a bit more independent from the bottom. So what we're going to do is just extend that a little bit more because we got caught a little bit. And now if we go to texture paint, there we go. So the top is perfect, the sides are perfect. The only issue we have now is, for example, if we were to paint some edge wear, so we were to go, okay, well there's a bit of an edge there, we'll see that it doesn't truly line up like so. It can if we do it in our 3D viewport, but if we're dealing with our 2D softwares like Photoshop, Paint, GIMP, whatever you use to create textures, you'll have to try and go, okay, so if my scratch is here, then it means it will sort of carry on there. As you can see, I missed that by quite a bit, so there we go, somewhat redeemed myself. You then have to start guessing, and it's just easier to sort of go, if there's a scuff here, you just want to paint one singular edge, almost the equivalent of just doing this, because then it translates well, and then you've got it here. But as you can see, so even though I'm painting the top there, you'll see that the pixels do come out, and again, this can be fixed if we had a higher resolution image and we have our UVs unwrapped. Don't get me wrong, this is a cylinder. If this was a cube, for example, so obviously we've got our rectangles for this, and they are at an angle, but if we had it like our can, for example, so if we just grab that real quick and we go into our texture paint, if we've got these perfect vertical lines, then what we can do is we can literally just come down here, and then we can say paint down like so. That might bleed in that second one, but as you can see, yeah, there you go. So it's not bleeding into the adjoining face, and of course, because it's separate from the bottom circle, we can just do that, and then we're fine here. When unwrapping an object, you want it all to fit inside the UV space. However, not all the faces need equal space. So, for example, with our billboard, the border doesn't need much UV space as it isn't doing most of the heavy lifting. This will just be a brief perimeter with a texture of metal, say. But because the billboard itself is going to have a lot of good detail, we'll prioritise this face to take up more UV space, but don't give it too much that it starts to take away from other sections of the mesh. So if we look at this as a whole, we'll see that we've got all this empty space towards the top, and what we can do is we can just grab these faces, for example, bring them down here. We can also grab those and move that accordingly over here. And then if we delete the back, say, because we know the back doesn't get seen, and now we've got our face. So what we can do is we can rotate it for 90 degrees, and then we can bring it up here, and then as you can see it's upside down, so if we just do a 180 degree spin, and then if we just grab all of these and do the exact same, turn it by 90, and then what we can do is we can scale this up, so then we are maximizing the amount of resolution that this can get. So we can also grab these, for example, and then we can just bring them down here and then rotate them 90 degrees and even shrink them. Don't get me wrong, we can rotate them like so, and then yeah, there's our billboard with Maximise Space, so that we can get better quality. But again, what not to do is if we were to put a metal texture on this perimeter, that these are so small that they look grainy, pixelated, and then take away from the main billboard. In your images on your object. So for example, a starry sky will look like a blurry sky, and in our example here we're going to use our UV grid for its designed purpose, and we're basically just going to analyze what happens in real time if we start pulling our UVs where we shouldn't be going. So this is basically them stretching and distorting. So if we pull out this bottom vertex here, and then as we can see, that is visibly stretched. So Blender does have a tool that we can use, and it's built in, where we can look for stretching, and that can be activated here in the Overlays tab. So if we just tick this, we'll see that dark blue means fine, and our greener just basically means it's being stretched. So you have to kind of pick and choose between these two, because these basically just look for, is it a polygon? So for example, if you pull this here, we can see it's visibly stretched, but it's saying it's fine. But if we activate our area, this is now saying it's basically upset the rest of the model, and then this is orange basically saying it needs sorting. So as we slowly pull these back out, not only do we see our main mesh start to turn a darker blue, but we see our face that we're impacting becomes a darker blue as well. So now we've hit the sweet spot, and we know that this is relatively fine. If you want to do a lot of your texturing in another 2D software, but you just need a guide as to what goes where, what you can do is you can export your UV layout through Blender by going to UV, and at the bottom export UV layout, and then you can name it whatever you decide. So I'm just going to call this our UV Cube 1K, and then I'm just going to overwrite and then export that way. So just because you can model in Blender and you can texture paint and make shaders in Blender doesn't mean you have to. So yeah, you can export the UV layout to act as an overlay in another software. So for me, in this short example, I'm going to be using Paint, and so long as you know which face goes to which part, you can then export your image and apply it to your 3D model. So in my case, it was a simple can, and I know that the left circle of the UV is the top and the right circle is the bottom. So then I use that information accordingly to make my can. Thank you for watching, and I'll see you in the next one.